Hello students, today we are going to discuss topic Bernoullis theorem. So Bernoullis, he is only developed Bernoullis theorem. So what he developed, consider one pipe. Okay, so consider one pipe. This pipe having two variable cross section. Cross section means that is the area. So here this is the area A1 and A2. Here A2 is greater than A1. Okay, so two variable cross section. When the liquid is flowing through this tube, okay, so what will be happening? Okay, so he is developing his ideas through when the liquid is flowing through this two variable cross sections. Okay, so what will be happening? Okay, then he is based on the theory. This theorem based on the conservation of energy, and also this theorem is only for streamline flow, not for turbulent flow. It is only for streamline flow. Okay, do you understand? So what this theorem state that means when the liquid is flowing through this tube. Okay. When the liquid is flowing through this tube. Okay, so here it having three energies. What are the energies means? So first one, pressure energy. Pressure energy. So you know that liquid always flowing from higher pressure to lower pressure. So it having some pressure energy, first point. And second one, it having potential energy also. Okay, and second one, it is a potential energy. And third one, pressure energy, potential energy, and third one, kinetic energy. So when the liquid is flowing through this horizontal, flowing through this any one type, okay, any one pipe, it having three energies: pressure energy, potential energy, and kinetic energy. So Bernoullis theorem states that the sum of these three energies is equal to the sum of these three energies. What are the energy? Pressure energy, potential energy, and kinetic energy. The sum of these three energies per unit mass is the sum of these three energy per unit mass is equal to constant. Okay, the sum of pressure energy, potential energy, and kinetic energy per unit mass is equal to constant. So this is the Bernoullis theorem. Okay, now we are going to prove that this theorem. So how to prove that? So consider one pipe like this. Okay, so it will be placed at certain height. So this is the point A and this is the point B. So point A having the height h1, and from the point B, from the ground, it having the height h2. So here h1 is greater than h2. Okay, and point A is having area AA, and point B also having that area AB. Okay, small a is the represented area. So here also AA is greater than AB. Okay, so AA is greater than AB. Small a is represented area of cross section. Here AA represented area of cross section at the point A, and AB represented area of cross section at the point B. Okay, then next, pressure. So when the liquid is flowing through this pipe, it having that pressure, that point A having that pressure is PA, and point B having the pressure is PB. Okay, so because here that wall area is different, and B is different with area in B. Okay, so pressure is also different. Okay, so here PA is less than PB, because when the area is very larger, the pressure will be very less. Okay, when the area is very less means the pressure will be larger. Okay, do you understand? So already we know that. And pressure energy PA and PB. And what about the volume of the liquid? So volume of the liquid is constant. Okay, volume of the liquid is VA and VB. So this represents that volume of the liquid. When the volume of the liquid at entering that point A, okay, volume of the liquid when the entering at the point A, it having the time T. Okay, so this will be equal to when the liquid is leaving at the point B, okay, at the same time, that volume also same. It means when the entering that volume of liquid VA, volume of the liquid VA, and at the same at the particular time interval T, okay, at the same time at the point B, the liquid will be leaving from that point B, it having that volume VB. So both the volumes are same. Okay, so here height is variable, height is very different, and area is different, pressure is different, but volume of the liquid does not different, it is same. Okay, do you understand? Then next, now when the liquid is flowing through, when the liquid is entering this pipe, okay, from A to B, this liquid is moving. From A to B, this liquid is moving. Okay, ma? Do you understand? So it needs some work done, or it must having some work done. Okay, otherwise that liquid does not flowing from one place to another place. So when the liquid is flowing from, if the liquid is flowing, wants to be flowing from A to B, it needs some work done. So that work done how much? Okay, so work done is equal to, what is the formula? Work done is equal to force into distance. Okay, so here the distance between point A and B is small d. Then work done is equal to force into distance. So force, so which point we want to be taken? When the liquid is only entering at the point A only. Okay, so this point only needs the work done. So you can choose that point A. So that point, how much force experience that the liquid? Okay, so FA into D. So force, how to find out that force? You know the formula, pressure at the point A. Pressure is equal to, what is the formula? Pressure is equal to force per unit area. Force per unit area. Then force FAA is equal to PA into AA. Force equal to pressure into area. Okay, do you understand? So this is the equation number 1 and this is the equation number 2. You can substitute equation 2 in 1. So work done W is equal to FA. You can substitute what is the formula? PAAA. PAAA into distance D. Okay. Then PAAA into D. Here A is the area and D is the distance. Area into distance. What is this? Area into distance. This is called as a volume. So volume is equal, V is equal to area at the point A into distance D. Then volume, okay. When the liquid is entering the tube, it is having velocity, you know. So that velocity is VA, small VA. Okay. So leaving the point B, it is having the velocity VB. VA is the velocity at the point A and Vb is the velocity of liquid at the point B. Okay, so velocity is equal to at point A, Va. Velocity is equal to, what is the formula? Distance by time taken. So d divided by t. Va is equal to d by t. Then d is equal to Va into t. D is equal to Va into t. Now you can substitute this equation number 3. This is the equation number 4. So substitute 4 in 3. Okay. So W is equal to PA, AA and D. You can substitute PA, AA and D. You can substitute what is that? VA into T. Okay. Then work done is equal to AAVAT. So this is also known as the distance, and AA into D. Okay, so PA AA into D. So area into distance. What is this now? Volume. So work done W is equal to PA into volume. Okay, so this we represent volume and this we represent the velocity. So work done is equal to pressure at the point A into volume of that liquid. So what is this? This is called as that. This is already you know that this is known as pressure energy. So pressure energy is equal to PA into V. Okay, pressure energy is equal to PA into V. Okay, do you understand? Okay, then next pressure energy per unit volume. Pressure energy per unit volume is equal to pressure energy. What is the formula? PA into V divided by V. So volume cancel. That's equal to PA. Then next pressure energy per unit mass is equal to PA volume V divided by mass M. So here volume divided by mass. What is the formula for density? Density rho is equal to mass per volume. Then volume divided by mass is equal to 1 by rho. Okay, you can substitute this. So pressure energy divided by mass M is equal to PA divided by rho. Rho is the density of the liquid. PA is the pressure at the point A. Okay. Then next pressure energy per unit mass is pressure A at, divided by P. Then next, when the liquid is flowing, okay, at the point A to B, it having some amount of liquid, that is mass will be including. Okay, so mass of the liquid, you know that. Okay, mass of the liquid it need. So mass of the liquid you can multiply with M and divide with M. So pressure energy per unit mass, then no. So pressure energy is equal to pressure energy is equal to PA into V and divided by, you can multiply with the mass M and divide with the M. So PAV M by M. Then M PA V by M. What is that? V by M. V by M is equal to 1 by rho. So pressure energy is equal to M PA by rho. Okay, so this is the equation number 4. Then next, potential energy of that liquid at the point A. Potential energy. PE represents that potential energy. Here P, suppose if I put a PE means it is the potential energy. So we want to vary this symbol. So only I shortly write this pressure energy. This is the potential energy. So potential energy of that liquid. Potential energy is equal to, what is the formula? mgh at the point A. So potential energy is equal to mgh A. Okay. Then next, kinetic energy of the liquid. Kinetic energy of the liquid, what is the formula? Kinetic energy is equal to half mv square. So here m is the mass of that liquid and h is the height of the pipe from the ground at the point A, and VA represents the velocity of the liquid at the point A. Okay, so potential energy, kinetic energy and pressure energy. So this you can sum up these three energies. So this is the equation number 5 and this is the equation number 6. You can add in these three equations. So this total energy at the point A is total energy at a point A is pressure energy m PA by rho plus potential energy mg HA plus kinetic energy of mv square A. Okay. Then next at the point B. So this is the point A and point B. So these are the point A having pressure energy mPa by rho. Okay. Suppose the liquid is leaving from that at the point B. So what is the pressure energy? So pressure energy at a point B is m at the point B. Pressure energy is equal to, at a point B, pressure energy is equal to what is the formula? mPa by rho. So m P by rho, because the pressure at the point B. Rho is the constant because density of the liquid is a constant only. And next pressure energy, then next potential energy. Potential energy at the point B, mg HB. Okay, so this is the HA and this one HB. Okay, so mg HB. Then kinetic energy. Kinetic energy of that point B is of mv square B. Of mv square B. Then next you can sum up these three energies at the point B. So total energy at the point B is total energy at the point B. Okay, so So total energy at the point P is the sum of pressure energy, potential energy and kinetic energy. So you can add in these three equations, these three energies. Okay. So M PV by rho plus M GHB plus of M V square B. Okay. So according to conservation of energy, what is conservation of energy? Energy cannot be created, not be destroyed, but it transforms from one form of energy into another form of energy. So here at the point of energy A, okay, so this energy will be equal to at the point of B. Okay, so energy at the point A, total energy at the point EA is equal to total energy at the point EB, the point B, that is equal to EB. So this is the EA and this one is equal to EB. Okay, so you can adding these two equations, equating these two equations. EA is equal to EB. So M PA by rho plus M GHA plus of M V square A is equal to M PB by rho plus M GHB plus of M VB square. Okay. So in all the terms having only one physical quantity is constant. What is that physical quantity? M. So all the term is having M. So you can divide with M. Okay. So PA by rho plus GH plus V square A by 2, that's equal to PB by rho plus GHB plus V square B by 2. This is equal to constant. Okay. So at the point A, you can vary any quantity, that is pressure or velocity. Okay. At a height. Okay. So if you vary, you can adding this energies. This will be is equal to constant, and B also having that same energy. So that is you can substitute at the same other values. You can substitute that values from at the point B, so you can get that constant value. So you can simply write this P by rho plus GH plus V squared by 2 is equal to constant. Okay. So what is that Bernoullis theorem state that the sum of pressure energy, potential energy and kinetic energy per unit mass is always to be a constant. Okay, do you understand, ma? Now in your book another one step is given. You can divide it with the G also, so you can get P by rho G plus H plus V squared by 2G is equal to constant. Okay. So this theorem is only applicable for non-viscous liquid and streamlined flow of liquid. Because why means, and without losing energy only it is a value. Okay, so this theorem only based on the conservation of energy. So at the point total energy at the point A is equal to total energy at the point is B. When the liquid is entering at the point A, so it flowing through this pipe. Okay, so the total energy at the point A is equal to total energy at the point B. In practical, it is never equal because it having some resistance. When the liquid is flowing through this pipe, it will be affected by that some resistance, that is viscosity. Okay, so only we need this theorem only applicable for non-viscous liquid and incompressible liquid. Okay, non-viscous liquid and incompressible liquid. And next one, suppose this is the horizontal pipe. Okay, and height is equal to 0. There is no height. This height is equal to 0 means, what is that Bernoullis theorem mean? P by rho g plus v squared by 2g is equal to constant. So this is the Bernoullis theorem. Okay, ma'am, do you understand? Okay, thank you.